Show that the cross section for elastic scattering of a point particle from an infinitely massive sphere of radius r is r square by 4. What is the inference of this result? This question appears in IAS 2019. This is 10 marks question. Let's try to solve it. Now mathematically, cross section or popularly known as differential scattering cross section is given by sigma phi is equal to minus p upon sin phi into dp upon d phi. Here p is impact parameter and phi is scattering angle. Now for rigid elastic sphere, this is a rigid elastic sphere with center O. This line of axis passing through the center. Now this is a beam of the particle coming toward the sphere at a perpendicular distance p, which is also known as impact parameter. Now after striking the sphere, it gets reflected. Now because this impact is perfectly elastic, so it follows law of reflection. Now if you join this point O and the point of strike, and if we extend a line of incident, then this angle between incident and reflected ray is known as impact, is known as scattering angle. Now because this total angle is 180, so this angle is pi minus phi by 2. Similarly, this angle is also pi minus phi by 2. Now this angle is also pi minus phi by 2. And this distance is the radius of the sphere r. Now we can write P is equal to, which is the impact parameter, P is equal to R sine pi by 2 minus phi by 2. That is equal to R cos phi by 2. This is the first equation that gives the relation between the impact parameter and scattering angle. Now let's differentiate this, then dp upon d phi is equal to minus R sin phi by 2 into half. This equation 2. Now let's put the value in expression of scattering cross section from equation 1 and 2. So we can say sigma phi, that is our scattering cross section, is equal to minus P upon sin phi into dp upon d phi, that is equal to, here the value of P is R cos phi by 2, so it is minus R cos phi by 2 divided by sin phi into minus into minus R by 2 sin phi by 2. Now that is equal to R square by 2 into sin phi by 2 cos phi by 2 divided by 2 times sin phi by 2 cos phi by 2. Because sin phi can be written as 2 times of sin phi by 2 cos phi by 2. Now that is equal to R square by 4. Hence proved. Now let's find the total scattering cross section. That is sigma is equal to integration sigma omega bracket d omega, which is equal to R square by 4 integration d omega, which is equal to R square by 4 into 4 pi is equal to pi R square. Now that proves that total scattering cross section is pi r square which is the area of projection of sphere in the plane perpendicular to the incident beam. Next, scattering cross section sigma is equal to r square by 4 signifies that intensity of scattered particle is independent of scattering angle. That proves the system is isotropic. Isotropic. Thank you.